Hello, good morning. Good morning to all of you. Today, we would like to consider AES algorithm, and we will see how AES algorithm could be. So, already we have completed this particular part in the previous session. Since I haven't taken classes for the past 5 days or 4 days, so that is why I have been displaying this one more time. So AES is an algorithm which is a block cipher, symmetric block cipher, which could be done using 128-bit as input and providing 128-bit as output here. And the key length might be either 128, 192, and 256. Any one of these. But we are supposed to discuss about only 128 key bit. And it was actually introduced by Rinzal cipher, which was created by Belgium scientists, Belgium cryptographers. Already we have discussed this one. So it could be taken 128 bits or 192 bits or 256 as key sizes. So it could also be taken in one of these, but we people are discussing regarding to only this particular point of view, 128 bits only. And A standards, a block size will be, block size in the sense input plain text size will be 128 bits, and output could also be considered as 128 bits. Okay, so this could be AES here. So then this Rindal key, whatever the Rindal key could be available with us. So Rindal key could be considered as a Rindal algorithm could be considered as AES, which was decided by NIST in the previous years. Okay, however, this is not important for us because we have discussed everything here. So total number of rounds which could be done by this particular AES will be based on the key length. So key length will be equal to 128. It could be taken 10 rounds. And the key length will be 192 bits. It could be taken 12 rounds. And the key length will be 256 bits. It could be taken 14 rounds. Okay. So, but we have, so as far as our syllabus is concerned, we have to discuss about only 128. So 10 rounds are supposed to be taken into consideration. And it could not be Fiestel network. It is having its own one structure. Let us discuss that particular structures today. Okay. So, however, so this is the structure where exactly we have to consider here. Plain text will be X will be the plain text. And so key must be added to the particular plain text. This particular round could be taken by me after probably by tomorrow class. It could not be explained at this moment right now. So transformation of a key and a transformation of addition of a key could not be taken today in the sense. And every round has included 4 different types of operations. Number 1, byte substitution. Number 2, diffusion layer. This diffusion layer internally having 2 more extra rounds. That is shift rows layer, and mix column layer. Okay, rows will be get shifted and columns will be mixed based on S boxes or some other way. And finally, after mixing could be happen, then the key will be gets added to that particular mixed item or mixed column. So these 4 different kinds of layers will be continuously gets operated in each and every round. In each and every round, these 4 operations could be gets happen continuously. Okay. So these 4 could be gets happen continuously. And finally, so that number of rounds will be already we have taken. So 128 bits will be taken into consideration. We are trying to take only 10 rounds into consideration here. So this is 9th round, and this could be the 10th round. In 10th round, we don't have any mix column. We don't have any mixed column. So by on elimination of a mixed column at 10th round, so we have been taken this many number of layers. So output of these layers will be called as so ciphertext of your final AES. Okay, this is very high level diagram. So rounds diagram, which is very high level rounds diagram here, which is so being taken into consideration in the final examination also. Actually, this is underneath of this one. It could be underneath. So this whole diagram must be underneath of here. So you need to draw at this place. However, so these four so layers are supposed to be used. These 4 layers are supposed to be used in every round. So that is 128 in the sense up to 9 rounds we have to use the same number of layers to be considered for encryption. And the 10th round, for example, if you take this one here, 10th round, so we need to eliminate mixed column layer from this particular round. And after doing these 3 layers, so that what is the output? That output will be called as so your ciphertext. Okay. And today we would like to, if possible, today we would like to consider what is this byte substitution layer and what are these 2 here. And if possible, so we will continue with the key addition layer also. It's a very big lecture today. So I don't know whether it could be completed within 40 minutes or not. And tomorrow lecture, we may be taken how the key will be transformed and how the key will be, subkeys will be gets operated. It will be taken by tomorrow. Probably key addition could also be taken by tomorrow. Okay, if things will not be permitted me, I'll go for tomorrow. Otherwise today I'll complete. So however, let us see, it's very important to remember. So here, each round within AES will be considered as 4 different layers. First layer will be byte substitution. Second one will be shifting the rows. How the shifting rows will be gets happen. Let us go in detail. So then mix the column, and finally key addition. So here it could be considered as a provides the confusion operation. Already we have taken in the DES structure itself. So as far as the encryption or decryption standards, confusion and diffusion must be there in terms of any symmetric ciphers. So byte substitution could be always gives you confusion, and so this could be provides the diffusion here. So diffusion could be takes place. So confusion could be always achieved by implementing S boxes. Diffusion will be always implemented by taking permutations. Okay, so permutations. So by taking this particular permutation, a diffusion could be so achieved here. And finally, after confusion and diffusion operations, layers, we would like to go ahead with so the key addition. Okay, and this particular process will be continued for several number of times here. Okay, so as I just before given that last round does not have any mixed column layer, I have already given. So nth round could not have any mixed column layer. Okay, that is the point you need to observe here. And AES subkeys. So already I have given. So this addition of keys will be took place, which is called as key whitening. Key whitening in the sense mixing of keys. That is the meaning of this key whitening here. Mixing of keys with normally key whitening could be always done by taking one operation here, very familiar operation in computer science, that is exclusive OR operation. Okay, by operating exclusive OR, it could be considered as key whitening. Then followed by, before going to do these 4 layers, what exactly this particular AES algorithm can be done here in the sense, all these 128-bit data will be split into 16 bytes, 16 bytes, 16 bytes, and so on and so forth. Okay, and how this could be done? Let us see. These are the rounds here. So A will be the plain text, for example. A will be the plain text, and which does have 128 bits. And this A will be taken with the first layer. That layer is called as a byte substitution. byte substitution. After one moment, please. One moment, please. Yeah. After byte substitution, so we'll go ahead with so shifting the row. So this is the confusion operation, and the diffusion operation will be rows shifting, and then followed by mixing columns. These two will be collectively called as diffusion. After this one, we have to add key. Key must be added to the each and every row. So these are the four different types of layers which have been happening here. Then what would be taken? What would be taken? So at the byte substitution level. So look at this. It's very important to remember, or it's very important to draw this particular diagram in our final examination. Look at this. So already I have told you, so it could be split into so number of bytes. So it could be split into 8 plus 8 plus 8 plus 8, totally 32 bits. So A0, A1, A2, A3, each A1 or each block will be called as 8 plus 8 plus 8 plus 8. 4 8s are 32, and again 32, and again 32, and again 32. Because each and everything will be so 8 bits of data here. This is 8 bits of data, and of course last one also 8 bits. Each and every part will be, each and every room will be 8 bits of data which is being available. So this 8 bits of data will be transformed to, so or will be given as input to one S box. Each and 8 bit will be taken, so one S box as input, and here also will be produces. So after taking this particular S box, what exactly this X box will be done? Already we have seen in our DES. So of course not exactly like that, but here somewhat more efficient kind of S box will be operated here. However, this B0 and A1 will be sent through. So S box will be generates B1, B2, and so on. And similarly, here also same. And similarly, here also same. 16 different kinds of 16 different kinds of S boxes are supposed to be gets operated here. Operated here. So every S box is identical. So in DES, we do have approximately okay, every S box in a DES we have seen 8 S boxes are there. All these 8 S boxes will be so different, and it could be have 48 different tables are which are available with us. But here we do have only one S box, and this S box will be so transform its output to so A0 to B0 and A1 to B1, A2 to B2, and so on and so on and so forth. So actually this is A12 it is. Actually this is A12, A13, A14, and A15 actually. I have mistakenly given something A13, something like this. However, whatever it may be, so 16 S boxes are supposed to be gets operated here. So after taking this particular thing, this whole thing will be called as a byte substitution. This whole thing will be called as byte substitution. How this could be done? So this A0 will be, for example, A0 will be have this particular value. Let me say some 25 is A0 having this particular value. For example, this value could be existed in terms of hexadecimal form. It is in hexadecimal form. So it could be look into, this 25 could be look into the S box table, something like this. First one, this first particular thing will be called as, this is a row number. And second thing will be, this is called as a column number. So based on this one, it could be gets identified, and it could be, so gives you some value here. Okay. So in this way, so every A0 will be taken into consideration, something like this. So if you convert this particular 2, 5 into its binary equivalent, hexa equivalent binary, 2 will be written 0, 0, 1, 0. This is 2. As far as hexa based binary, 5 will be 0, 1, 0, 1. So this is hexadecimal equivalent value for 2. and this is hexadecimal value for 5 here. So A naught will be, so let me consider this is A naught, which is having this particular value. And in terms of binary, A naught will be seems in such a fashion like this. So therefore, so this will be look into rows, and this will be look into the columns. This will be look into that particular column. So therefore, based on the row and the column, you could get one particular value in a proper way. I'll display that particular so table in the next slide itself. Okay. So in this way, you have taken into consideration. After the plain text will be divided into so 8 bits consecutively, and first 16 bits, sorry, 32 bits will be called as one block, second 32 will be another block, third 32 will be another block, and so on. 4 32 blocks will be taken. Each and every 8 bits will be always sent through one S box here. One S box here. The output of this one is 8 bits, and here also the output will be 8 bits here. So after generating the output of S box, it could be called as B naught. It could be called as B naught. So output B naught will be called as substitution, byte substitution. Okay, output B naught will be called as the output of this whole S box will be called as byte substitution. After this particular row and after this particular kind of thing, what exactly the specification will be, then how the shift row could be gets happened here. I'll show you how the shift row could be gets happened here now. So shift row could be takes place something like this. So the shift row will be the input of mix column. So how this could be? B naught will be so taken into consideration of the mix row, and so B4. Let me say the fourth input will be B15 will be taken. So this particular thing, something like this. Here we have. I'll show you the complete table in the next coming slides. So in this way, the shifting is being happening here. So look at this. I'll draw something here. So B naught will be here, and B5 will be here, and B9 will be no, not B9, B10 will be here. So B10 will be comes to this particular column. So B5, B10 will be come to this particular column, and B15 will be the first column. Second column will be so B4. So first one is B1, and then B4, and then so B8, and then B13, something like this. Like this, the shifting is gets happening continuously. I'll show you that particular matrix. Based on the matrix, you could understand how the shifting will be gets happened here. Okay. First mixed column could be B0, B5, B10, and B15. First mixed column is that one. Second mixed column, let us see. Third mixed column, let us see. Fourth mixed column, let us see. Okay. So the inputs of a mixed column will be, so in this way, the shifting could be gets happened here. So this total thing, this total, let me say this particular procedure, this whole procedure is called as shifting of rows. Okay, shifting of rows here. This whole procedure will be shifting of rows. After taking this one, how mixing could be gets happened here. So we would like to discuss this one very, very carefully and very, very importantly. Then the output will be, each and every output will be, so here key will be having 128 bits. Already we have taken this information, 128 bits, and these 128 bits will be again divided into 8888 bits by transforming some kind of so notation here. We will give you that particular notation very soon. So this could be 8 bits, and this is also 8 bits. Okay. So first column KI1, so second column KI2, KI3, KI4, KI5, and so on. For each and every round, it could be created 16 subkeys. For each and every round, it could be created 16 subkeys. And so whatever the first value, which is first byte, which is available at this particular mix column, that could be exclusive ORed by the sub key, which is being taken into consideration. And the output will be called as C0. The output will be called as C0. So here also one more, that is exclusive OR. So that is C1. So here also exclusive OR with one more key. So here, whatever the key you have been operated here, the key value will be, let me take another color. The key value will be, so here, so ki2, I2, ki2, this is the input for this one is k, so I3, I comma 3. So it will be called as ci2 and so on. So ci5, ci6, i7, i8 and so on up to, so this is c, so c15. So in this way it has been produced. Okay, ci0 to ci3 will be first, so 32 bytes, sorry, 32 bits, and I4 to, so I7 will be second 32 bits, and third 32 bits will be seems like this, and fourth 32 bits will be seems like this. And this particular procedure for next round, C0 to C15 will be the inputs. Based on that, it could be do some kind of 4 rounds. Again, byte substitution and shift row and a mix column and a key addition. Everything will be done for second time also, and third time also, and fourth time also. Like this, approximately 9 times could be gets happen. At the 10th round, mix column cannot be there. Instead of a mix column, I mean, instead of 4 sublayers, we have been taken byte sublayer 1. First one is byte sublayer, second one is shift row sublayer, third one is key addition sublayer. All of these 3 could be taken. What is the output of that 10th round? That could be ciphertext. In that way, it could be sent some information. So here, very important point to be remember here is, so for example, okay, let me go ahead and show that particular table here, then it could be very, okay, look at this. This is the S box table. This is the S box table. For example, let me go ahead with the previous slide, please, one more time. So for example, so I have been submitted, so 0, 0, 0, 0, and so on up to 128 zeros have been submitted here. For example, 128 zeros have been submitted here, for example. So first zero will be 8 bits. So 8 bits in the sense each and every zero will be considered 128 in the sense, sorry. First 8 zeros will be A0, second 8 zeros will be A1, third 8 zeros will be A2, and so on. So if you take first 8 zeros, it could be seems in such a fashion. Let me take one more. So 0, 0, 0, 0. So this is first bit, first hexadecimal bit, 0, 0, 0, and this is second hexadecimal bit. So how it could be look into S box in the sense 0 will be the row and this 0 will be the column. So look at the table here. Look at the table. If you go ahead and look into this table, so what are the values of 0, 0 here? 6, 3. 6, 3 will be the value here. So 6, 3 will be the value in the sense what is the output of, I mean, B0 value. So 6 will be, so 0, 1, 1, 0, followed by 3 will be 0, so 0, 1, 1. So this is the output of our value of B0 here, for example. Why I would like to specify this one here in this way, here in the sense, if one bit will be flipped, what could be the specification? To discuss that particular point, I have been discussing this one here. However, so A0 will be equal to 0, 0, 0, 0, 0, 0. So all zeros. So this is row and this is column. As for S box, so the output B0 value will be after taking the output from this particular S box, the output will be 0, 1, 1, 0, 0, 1, 1. Okay, 0, 1, 1, 0, 0, 0, 1, 1. So here, how many bits have been flipped here? So first bit, second bit, so then followed by third bit and fourth bit. Totally 4 number of bits are being confused here. Okay, 4 confused in the sense flipped here. So if you are supposed to give in such a form. Now let me change the input. Hope that you understand what I spoke to you. Now let me change the one more output. So instead of sending 128 zeros, I'd like to send first bit will be 1 value has been flipped, and the second bit will be, third bit will be, fourth bit will be, fifth, sixth, seventh, eighth, and all others are zeros. Only one bit has been flipped, for example, if you consider like this. Now this could be row value is 1. Now this could be column value is 0. So if you look into the particular table, so row value is 1 and a column value is this one. So therefore you to understand CA is the output here. CA is the output. Previously, what we got, all zeros will be sent. This is the output of B naught. Now, what is the B naught output? So C and capital A. C in the sense that is A, B, C. That is 12. 12 could be written in terms of 1, 0. So double 1 is 12. A in the sense 10. 10 will be written 1, 0, 1, 0. Look at this. Look at this. I have flipped only one bit. I have flipped only single bit here. Only one bit has been flipped. The previous input is all zeros. Right now the inputs will be so 1,000,000. So like this here. Oh, sorry, 1,000,000 in the sense it is not a CA. I'm extremely sorry. This is not CA because it is not 1. It is 8. Sorry, it is 8. I'm sorry. It is 8. We would like to look into 8. So this is 8 here. So let me go ahead and look into this particular matter. 8 in the sense this one. CD. CD is the so value of 80. So if you take what 80 value CD, so look at this C and D, E, F. Okay. So C value is 10. So double 1. D in the sense 12, 13. So 10. So 10. No, not 1011. 1011 will be 13. So 1010 is 10. 1011 11. So 1110. So this is not actually 1110. 1110 is C. 1101. Yes, this is C. That is 12. So then followed by D in the sense 13. So 1 1 I'm mistakenly happened here. Okay, let me take so 8 plus 4 12. 8 plus 4 12. So that is 1100 will be C. So 1101 will be D. Okay. Yes, look at this. So how many bits have been flipped here? So approximately we have given 1,000,000 and 4 zeros has given. How many bits have been flipped? So first bit, second bit, third bit, fourth bit. Totally 4 bits have been flipped as per the output of so S box here. So therefore, if you flip just one particular bit here in any location of so ENR, so you could see previously this is the output without flipping any bit by taking all zeros into consideration, whereas only one bit has been flipped here based on the so table, so it has been taken something like this. So therefore, confusion will be very effectively could happen here. Moreover, in DES, everything, whatever the so input we have been taken, first 32 bits could be so scrambled, and the second right side 32 bits could not be scrambled over there. But here, everything will be scrambled. Look at this. Every 8 bits will be sent through. So each and every S box. So therefore, it could be scrambled. Okay, it could be flipped. So confusion will be completely. So all 128 bits will be happened with confusion. So this is the powerful confusion which is being happening with the advanced encryption standard here. So this is the point you need to understand. And followed by you can see what is the byte substitution layer. Byte substitution layer will be, so look at this, byte substitution layer can be viewed as a row of 16 parallel S boxes. Just before we have witnessed 16 parallel S boxes will be taken, and each 8 input and outputs, each might be having 8 inputs and 8 outputs here. Okay, then so all 16 boxes are identical. That's what I have displayed one particular table to you. That is a single table which could be taken into consideration by all 16 S boxes. There is no so different kinds of boxes here. Only one S box will be there with us. And then here in this layer, each state of AI in the sense A0, A1, A2 will be replaced by substitution of S box which could be produced by, so bi, which is denoted as S of I. So S of AI. S in the sense S box of AI will be equal to BI. So that is the meaning here. S box of AI in the sense. So AI will be seems something like this 0, 0, 0, 0. Already one example also given here. So 1, 0, 0, 0 will be given something like this. It could be seems as 0 and it could be seems as 8. So 0, 8 will be the input of AI, and we have to look into the table at 0th row and 8th column. Whatever the value which we have, which is available in hexadecimal form, that value could be output of this one here. Okay, so that is the meaning here. Look at this particular table here. So this table is common for all S boxes. There is no change in this particular table. Everything is common here. For example, we'd like to consider, so it is a non-linear kind of operation here. What do you mean by non-linear kind of operation? As far as S boxes are concerned here is, byte substitution of A plus byte substitution of B cannot be equal to byte substitution of A plus B. So byte substitution of A, for example, A will be equal to, so 1, 0, so 1, 0, 0, 0, 0, 1. For example, this is A, for example, if you consider. So for example, this is B will be equal to, so 0, 1, 0, 1. So no, 0, 0, 0, 1, 0, 0. So 1, 1, 0, 0. For example, this is B. So consider, so if you send these two into separate so S boxes, what is the value of A here? Value of A will be equal to, so 10 in the sense that is more specifically speaking in terms of hexadecimal, that is called as A. That is called as A. So A and 1. Row value is A and column value is 1. So A1 in the sense you could see, so this is the value. 3, 2 will be the output of A here. And moreover, as far as B is considered as, output of this one will be 3, 2 here. 3, 2 here. And B will be, so what is the value of B? So 1, 0, 0, 0, 1, 0, 0, that is 4, 1, 1, 0, that is C. So 4C, 4 is the row, and C will be the column here. So C will be this one here, that is 2, 9. So which is equal to 2, 9 here. Okay, so this is the scrambled value, this is the scrambled value individually. If you add these two, if you are supposed to send byte substitution by adding these two, let us consider hexadecimal adding. So 1, 0, 1, 1. 1, 0, 1, 1 in the sense this is D actually. Okay, this is D. And this is 0, 1, 1, 1. So it could be, so E actually. So this is E. This is A plus B. This is A plus B here. A plus B. Look at this particular A plus B value, substitution of A plus B. So first one is E, and I mean row is E and the column is D. So E will be taken here and D will be taken here. So D will be taken here 5, 5. You could say this is 5, 5. Okay. So A plus B value will be equal to, so 5, 5 here. Even then if you add these two values, you could not get 5 here. That is 1. So carry 1. So actually 9, 10, 11. 11 in the sense A, B. So that is B. So 5 plus 2 plus 5. So that is 5B. Actually we got 5B, but A plus B value is 5, 5. Hope that you understand. These two values are not equal. Okay, general values will be A plus B equal to B plus A. That could be okay, but byte substitution of A plus byte substitution of B cannot be equal, cannot be the same. You need to understand. So this particular point here, this is very, very important in terms of so byte substitution as far as confusion process here. Then followed by, let us assume the input will be input of SBox. How you could set here already I spoke to you for a number of times. So AI will be equal to C2 in terms of hexadecimal. C2 in the sense, so let us take this is C and let us take this is T, C, and 2 in the sense this is 2. So let us consider this value. Therefore, the value of substituted value of so this one S of C2 in hexadecimal equal to 25 in XR. So that is what the value which we have got here. Okay. So therefore, you need to remember these points here. These points into consideration, and this is the so AES S box here. Okay. Then followed by, So diffusion. Diffusion layer is constructed by using two different types of sublayers. Then one is shift rows and second one is mixed column transformation. Shift row transformation and mixed column transformation. What do you mean by shift row here? What exactly the shift row could be considered here? The purpose of shift row is so increase the diffusion. Diffusion in the sense you must remember one thing, that is permutation. Okay, so permutation. Permutation will be always taken into consideration. This property of permutation will be increased. So look at this, how this could be. So shift row transformation will be take in such a form. I'll give you the matrix after some time. The transformation will be cyclically, it could be done. Second row of the matrix will be, state matrix will be, so take 3 bytes towards right. It could be shifted 3 bytes towards right side. Third row will be taken 2 bytes towards the right side, and the fourth row will be 1 byte towards the right side. Look at this. Okay, this first row couldn't have any change here. That could be same as it is. Look at this. Look at this. B0, B1, B2, B3 is the first column. B4, B5, B6, and so on and so forth will be second column, third column, and fourth column. So here we have taken the values in terms of column, but shifting could be happen in terms of rows. I hope that the name itself you have to identify as rows. So second row will be so transmitted. So for 3 bytes at a time. 3 bytes in the sense. So this row will be 3 bytes will be transmitted at a time. So therefore you could get so how the output will be. So look at this. So B5 will be thrown. So it could be considered as in first shifting B13, B1, B5, B9. That is the first shift. Second shift will be so B9, B13, B5, B1. So that is second, and so on and so forth. You could see after 3 different types of shift operations, it could be get something like this: 3 bits towards right, and it is 2 bits towards the right here, and it is 1 bit towards right here. So therefore, you could get these kind of inputs here. Okay. So that is why already I have 10, B0, B5, B10, and B15. You could observe, I'll go back to the previous slide. Yes, here. The shifting could be B0 will be the first one, and B5 will be the second one, and B10 will be the third one, and B15 will be the fourth one. So that is the input of a first mix column. Hope that you understand. That is the input of first mix column. Okay. So in this way, the mix column, the shifting row could be happen for every so mix column here. So this is the first mix column which could be applied in first round. This is the second mix column which could be applied for same first round, and this is third one, and this is fourth one. Everything will be in terms of first round only. After taking first round, these values will be again remixed for 9 times. 10th time also remixed, but I mean reshifted, not mixed, sorry, reshifted. 10th time mixing could not be there. Okay. As of now, I'm able to complete up to this particular point only because only 1 minute of time is there with me. So I'll go ahead and take what is the inner components of this mixed column sublayer and what is the key addition. So tomorrow we'll continue this one. Okay. So only